Hello everyone, I'm Juanita. Welcome to the Scientific Python interviews. Today we have Dan Schult. So Dan is a professor of mathematics at Colgate University in upstate New York. He co-founded the NetworkX, the scientific Python package for network science, and he's currently one of its maintainers. He has been part of the scientific Python community for a long time, helping grow the NetworkX community. So thanks for being here, Dan. Can you please introduce yourself?
Yeah, so I'm Dan Schult. I enjoy working with software. I think that started very young, and it always kind of attracted me to go toward the side of the programming or the software where you could change and adapt things. And I think that sort of instilled in me an open source view of the world where, yeah, I want to use a computer. I want to be able to do something with the computer, but I don't want to just be presented with what's there. I'd like to see what I can do with it to tweak it and make it sort of more fun. So that's where I'm coming from. Yes, I'm a professor of mathematics at Colgate University. It's a bitter cold winter here right now, and it's a wonderful place to be. So if you're ever in Hamilton, New York, it's about 5 hours north of New York City. Drop me a line and we'll go out or something.
Thank you, Dan. So I want to ask you what drove you to contribute to open source in the first place, and what was your first open source contribution?
Right, good. So I was a tenure stream faculty member. That's the way that the professor world works, right? You go for your first 6 years and you're on the tenure track. And so I did a lot of work with spreading of fire. I was studying combustion. And so you want to see how that spreads through the wood or through the forest or through the electrical wires in the space station or whatever it is. When I got tenure, I started looking around. This is an undergraduate institution, Colgate University is, and so sometimes they don't get to take the partial differential equations course until right at the end. And that's what combustion is all about. But also, this was near a pretty big breakthrough in the way that networks were studied. And so the idea of spreading diseases and spreading ideas, spreading memes, those kinds of things were just starting to be able to be explored in new kind of ways. I saw a really neat talk by Max Hyman from Los Alamos National Lab at one of the national meetings, and it was basically they were simulating a bio attack shortly after 9/11 as well, so they were interested in this kind of thing, a bio attack of a disease released in Portland, Oregon. And they had every single person in the city and, just fictional. And then they were simulating where they would go each day and how long they would be in this building or this room or that room. It was a really impressive thing to look at spreading, but not through wood or through space, but over a network. So you had this contact network of people infecting other people. So I decided to jump on that, and I went out to Los Alamos for my post-tenure sabbatical, looking to retrain a little bit, get into spreading over a discrete system instead of a continuous, meaning that you can infect somebody very far away from you if you travel there, and then come back, and now there's a site there that can start spreading as well. I worked with two people there, Eric Hogberg and Peter Swart, pretty intensely, and that's where I started to get into the publicly available open source software. As I said before, I'd always been interested in tweaking software and making that available to other people. You would post it on your webpage or send it out in an email list. But this was my first time where the official channels for releasing the software were fully developed at that point, and Eric and Peter were quite familiar with them. And so that helped me a lot to get involved. It was I was diving into the code to see what worked and what could be done better, and I was relying on them for a lot of the style and how do you make this usable by other people and that sort of thing. And I kind of got hooked. And so I started doing more of that stuff after that point. So it was 2004. Spring in 2004 was when it was about 6 months worth of time that I sort of more intensely got into software design and development for exploring spreading over these networks.
Wow, 2004? That's great. That's a long time ago. It sounds like your sabbatical was very productive.
Yes, definitely was. Yeah.
So how did you become a maintainer, like after all that? And what do you think was the greatest challenge?
Good. So so during that time, early on in that time, I asked Eric if there was some tool that he knew to play with these networks where you have nodes, individual nodes we call them, and we draw them as dots, and then we connect them with the lines, and that makes a network. It's often called graph theory in the mathematical world, but as soon as you put a number on that edge between the two nodes that says, for example, how likely is it to spread across this edge as opposed to another one? You can think of disease spread, right? Is it a 50% chance or is it a 10% chance? Then you get to what we call a network instead of a graph. And the network science was really ballooning at that time. So I wanted to try to play with these spreading processes a little bit. And Eric had this code that he played with, and he's invited me to take a look at it and see what that was like. By the end of the sabbatical, we had a pretty good, pretty robust system that other people would find useful. And Eric and Peter approached me about joining them to release that to the open source community and to maintain it at that time, from that time forward. It was pretty clear that Eric was the leader and sort of the spearhead that was making this move forward, but Peter and I were available to help, and that was a really nice way in. So that's how I became a maintainer, was that I was working with the code, providing fixes, making suggestions as to what might be easier, and they moved that to a larger scale. It no longer had to happen in a room where we would meet and talk about code. It could happen over across the country or across the world through the features that are available. They've been developed a lot since then, but at the time they were available, and so that was an important thing too. I think that's the greatest challenge, is to stay connected, to stay involved with that community, even though they are physically distant. And of course, more and more, we're doing more and more of that in lots of different realms, not just open source software. But I think that open source software was one of the areas that sort of pushed that envelope early on, to try to be able to work remotely, maintain a piece of software and not meet in a room. That's a pretty cool thing. So that early on, those were the challenges, is to stay connected.
And I think that's getting better through time, I guess.
Yes, much easier now.
So it seems that you're still leading the NetworkX project. So I wonder, how do you do that and also teach at the mathematics department at Colgate University? Right.
So I have a full-time job. The work with NetworkX is a hobby in some sense. So being a professor, part of my job is to keep current on the research. What's being published, what's being talked about, and some of that is the software that's being used. So it is part of my job to be looking at the software and playing with it. I'm going to call it playing with it because that's the way I view it. Figuring out what works well, what doesn't work well. It also became some of my interest in teaching came through in terms of rewriting the documentation, making it user-friendly, making it more academic, having lots of citations to papers that describe the algorithms. That was a focus of Eric's as well. So it worked well with my interests. We were sort of building a book, only it wasn't a book, it was a piece of software. But of course, this was a hobby too. So I would spend my time teaching, and there were months at a time where I was not able to really engage with the NetworkX stuff. And you can kind of see it if you look through the history that, oh, yep, okay, so he's coming back to that project again, and he forgot all the things that he did before, so he has to relearn them. That interruption, so to speak, was ameliorated somewhat by Eric, who I don't know where he got the time, because he had a full-time job too, but he was able to really fill out the package, put in important features that he knew people wanted to use, and also to be available, to give talks, to answer the emails. I was also answering the anytime somebody would have an issue, they could enter it into the web page and we could respond to it there. But he was instrumental in making that sort of grow. And this was during the time of my career when I was really pushing to become established. And so I didn't have as much time to venture forth into the open source and maintaining NetworkX, but I was active, and I tried to stay active, even though there were periods of months at a time when I really wasn't able to do it. I would come back to it, and part of that was because, again, the community. It was it's hard to stay together, but on the other hand, there was a trust there, and we knew that everybody was putting in what they could put in, and making improvements, and I think everybody in that crew really trusted that the other people were in good faith trying to improve the system. Also, year 5 to 10 or so after the release of NetworkX, it became clear that this was really helping a lot of people. When my wife goes to a conference and she's talking to people and they say, "Wait, your husband wrote NetworkX?" I use that all the time. That sort of thing makes you realize that this has implications far beyond what you intended when you first started. And that's really exciting to know that the work that you're doing is impacting people. Right? I have papers and people read those papers. That influences them, but the scale is very different with software. If you can do something that makes it a little bit easier to use the software, that's a big change, big help. Yeah. And if you can write a new algorithm, that's even better, big change and help.
Yeah, it sounds like your hobby helps a lot of people nowadays. So you were talking about how the community is very trustful. So I wanted to know, what do you think you enjoy the most about working with the scientific Python community?
Yeah, so there are two aspects of that. One, I'm a scientist. I mean, I'm in a mathematics department, and some people wonder whether math is science or not. But my perspective on mathematics has always been through a scientific lens. And so this is the community within the Python world, certainly, where the tools are being built to learn about the world, to explore the world using a computer. Python is... I had not been exposed to Python before I went to Los Alamos. I should say I knew of it. I had tried to use it a few times, but I had not actually spent much time using it. Python is a wonderful language, and I think that was part of the draw early on. And so there's these people that are doing science that are using Python because it's easy. You don't have to worry about the details of memory allocation and things like that. And you can write scripts as opposed to formulating all of the data structure and everything that you would need to write it in C. And you can actually see that if you're going to be doing a program and running it lots and lots of times and it's going to have to be really fast, then you should write it in C, no doubt about it. But if it's the people time that's important, which is usually the case in science, because you don't really know what question you want to ask yet. So you want to try this, try that, try the other thing. And that is where Python really shines. So the science and the Python kind of went together. You're saving people time by using Python as opposed to computer time, that's where you go and you write it in C or Fortran or some other language like that. The scientific Python community was pretty clearly, it developed, it sort of formed, I would say, around what is now called NumPy, numeric Python, and the array system to store matrices, to store data in an efficient way and have algorithms that could go through that data. So it was the right place for me to plug in. But what kept me there is that the community is an amazing community, right? We've got really good people who are interested in furthering the scientific knowledge, but also furthering the use of user-friendly, scientifically relevant software. And it's a community that is really built on being nice to each other. I mean, I don't know, we're all kind of, I think everybody, even the ones that are paid to do this, are being paid less than they would somewhere else. Everybody is sacrificing somewhat to be in this community, and we all know that, and everybody respects that everybody else is trying. There's no I'm sure there's politics somewhere, but I haven't seen much of it. It's a really good community to work at, and that's what I enjoy most about it. Is it's a safe place where I can go and I can do what I think is right and not worry about pissing somebody else off, and I can listen to what they say if they don't agree with what I want.
Yeah, I really love the sharing knowledge in the community. Like you said it, you just started a project that you thought it was useful for you, and then you share it, and then it ended up being useful for a lot of people. And I think that's really, really nice of the community. So where would you like this community to go in the future? Like, where will you see it?
Right. So scientific Python is, it has in the last 10 years gone through a vast expansion. But I think in the last, 3 to 5 years, there's been a realization that there are helpful ways that we can share tools and bring the tools together. And that's, I think, the sort of the nexus of a movement recently to form a community that is focused not just on one package or another package, but on the interfaces between them, to try to bring that community together to make the software not something that you download like NetworkX, you download NetworkX and just use that. Instead, you download a scientific piece of software that's larger, but lets you do all the different packages and interface between them nicely. And that distinction drops the barrier for people to use one piece of software and then move to another one and move back and forth between them. That's where I think the scientific Python community is moving, and where I would choose for it to go, but I'm just a very small part of that. But that's where I think there is benefit, right? The biggest bang for the buck is to take these pieces that we've got and make them work together in they already do, but in better ways.
Yeah, totally. I totally agree. So what do you think new NetworkX contributor should expect when they submit their first PR? Right.
So the whole PR and GitHub thing is a learning experience, and typically when you get to doing your first PR, you've played with it before, you maybe set up a repository yourself and done a pull request to your own repository to figure that
and made mistakes out. A lot of mistakes before doing that.
Make a lot of mistakes, and then you go try to read this page about how to do it and try that, and But eventually you get something, and it doesn't have to be fantastic code or anything. It might just be fixing a spelling error in the documentation, or rewriting some paragraph, adding a new paragraph that describes it in a different way, or different application that you happen to know about. So typically you get that. It takes a little while to get to that first PR, but when you submit your first PR, you will get it all ready, and you forked the repository to your account, and then you update that, and then you press the button to submit the PR to the next place, and nothing happens. And it's like, wait a minute, did that really work? I hit the button. And so then you go and you look, oh yeah, look, it's there. And so you can look at it and see what it looks like, and see what other people will see when they see it. You might expect right away within 5 minutes that you'll get somebody else posting back to it. It usually takes longer than that. But I would say with NetworkX, it's usually a 24 to 48 hour turnaround at most. So you'll get something from someone saying, thanks, this looks reasonable. If it's a documentation improvement, it might be as quick as, this looks great. Do you have any other changes that you expect to make? If it's more involved, you'll probably get some sort of a question like, wow, this is a really neat idea. We don't have something like that yet. Do you have any links to papers or other web pages that that tell us more about why that's an important topic? And so then you would respond to that. If it's a change in code that just speeds things up, right? You look through the code and you noticed, hey, this line could be changed and it would speed things up. Then we would probably get a response, something like, that looks like it makes sense to be speeding up. Do you have any idea how much it speeds it up? And the back and forth then starts. So then you reply to that reply, and the NetworkX folks will sort of walk you through what else needs to happen. Like if you put in a new module, but you forgot to put the link in, or didn't know to put the link into the documentation, we'll give you a tip for how to do that. We'll point you to the instructions for how to update the documentation, or to see the documentation before it's been merged with the main branch, so that your pull request, your PR, you can check out what the documentation looks like just with that PR added to what is already in NetworkX. So those kind of tips and tidbits are helpful. If you don't know about something, like you don't know how to time how long it takes, how much was the speed up, then somebody will give you a short blip of code, and you can take that and run with it and expand it, or make it work for your application. At some point, it'll start, if it's a more involved piece of code, it may get bogged down. Don't get discouraged by that. You know, if you don't hear for a week or two, ping us, right? Put something in. Any progress on this? That kind of thing can help. We've got things taking our time from stuff beyond NetworkX, and it's good to have a reminder to go back to it. And we're pleased to do so. It's not that you are bothering us or anything like that. And sometimes we'll just say, I can't get to it this week, but I hope to get to it 2 weeks from now, or something like that. That first PR then, once we have 2 people looking at it and saying, yes, this looks good, approving it, that's the official word, approving it, then it'll get merged, which means that we hit a big green button on our screen. And then
we go, yay!
And everybody goes, yay, yes. And the code gets put on top of the code that's in NetworkX. So that's the wonderful thing about this merging process, is that there's a record of everything that's happened, and it just interleaves the new code with the old, and then that's ready for release. So when the next release cycle comes, that will become part of the stable released version of NetworkX. And before that, it's available for people. Well, a lot of people just use the code straight from GitHub and not based on the release. Those are typically the more technically savvy, who are willing to put up with something that doesn't quite work right and then provide a fix for it. But the code is there and people do use it before it's released. So when you finish partying for having the PR merged, then you can start thinking, wow, that actually wasn't so bad. Let me try that again in a different way.
Totally. So anyone basically can do a PR.
Yes, there's the only hurdle to it is learning enough about the GitHub process where you can go in and make a copy of the repository, change something, put it up onto GitHub, and then press that button that says make a PR, put in some text saying what it's about, and then hit return.
I really like that about open source, that you can just get direct contact with developers. Okay, so one last question for you. I would like to ask you if you can give some advice to someone who wants to contribute to scientific Python ecosystem. So you already told us how PRs work. So what advice would you give to someone who's like, I want to do my first PR?
Yep. If you want to do a first PR, a great way to do that is to look through documentation. There's almost always something there that could be improved. And it's easy for the people in that are the maintainers to look at what you did, make suggestions or expansions. It's a relatively easy PR to make. At that point, then you go through the process of making it. But in that, I would say you shouldn't just pick one because you want to make a PR. Maybe I'll pull back on that. What you should really do is find something that is fun to do with this code, and work with it, and find out how it works and what makes sense and what doesn't make sense. And as you go, keep track in the back of your head. Oh, that was relatively difficult. I could probably make that a little bit easier to understand. And jot it down or change some, keep a version of your code and change something as it goes. As you are working on your stuff, that's where you're going to make the best, I think, changes for other people, because they're going to try to do the same sort of things that you're going to do. And if you can make it easier for them, then you've contributed to their work as well as your work. It also keeps you focused on something fun. So, choose something that you want and that you like. Make it a hobby, right? It's we're all giving, but we're giving in ways that make us happy. That none of this should be drudgery work. It should be something that you're interested in, that you are doing.
Yeah, I think it could be really fun to work on a project that you're really interested in.
Yep.
Okay. I think that was it for today. Thank you very much for being here today and for helping us understand a bit more about how you started on this journey of scientific Python community. Thanks all for watching, and welcome to the scientific Python community.
Great, thank you.